Welcome to Get Your FRQ On. This question is from 2009. It's question 5, and it is not calculator active. In the question stem, we have a table of values for x and f of x, and f is given to be a twice differentiable function. In part A of the question, we are asked to estimate f prime of 4 and show our work. Now, when we have a table of values for a function and we are asked to estimate the derivative of that function at a point, typically what you would need to do is use the formula for average rate of change over an interval, and that interval would have to include the x value where we are interested in estimating this derivative. So based on the table, we have x equals 3 and x equals 5 given to us in the table. Typically, I try to use the smallest interval that contains the point of interest, so I would use 3 and 5. My understanding is you don't actually have to do that as long as you are using an interval which includes x equals 4 in this case, but I wouldn't recommend it. I think you're probably just going to find it a lot easier to use the smallest such interval. So assuming we use x equals 3 and x equals 5, the derivative of f at 4 would just be f of 5 minus f of 3 over 5 minus 3. Those values we get directly from the table. F of 5 is negative 2, f of 3 is 4. So we get negative 2 minus 4 all over 2, which is negative 6 over 2, which is negative 3. In part B, we are asked to estimate the integral from 2 to 13 of 3 minus 5 times f prime of x dx and show our work. There's a couple of different ways to do this. You could split this into a couple of different integrals, use some properties of integrals, and evaluate them separately, or you could just take it for what it is. This is a function, and we're going to find the antiderivative of this function. The integral from 2 to 13 of 3 minus 5 times f prime of x dx. The antiderivative of 3 is 3x. The antiderivative of 5 times f prime of x is just 5 times f of x. And if I want to evaluate that between 13 and 2, 13 times 3 is 39. F of 13 we get from the table. I believe f of 13 is 6, so we get 39 minus 30 as the first part of this integral. And then putting 2 in for x, we get 6 minus 5 times f of 2. F of 2 is 5. I'm sorry, f of 2 is 1, and 5 times that is 5. And then the rest of it is just arithmetic. We get 9 minus 1, which is 8. So the integral in question here is equal to 8. In part C, we are asked to use a left-hand Riemann sum to approximate the integral from 2 to 13 of f of x dx and to show our work. One of the main things to understand about free response questions where you have to either calculate a left-hand Riemann sum or a right-hand Riemann sum is you have to show this sort of sum of products, right? You have to show that you are multiplying a width by a height for each of the necessary intervals. So for this one, our first interval is from 2 to 3, so we're going to do 3 minus 2 as our width. Because we're doing a left-hand Riemann sum, our height is coming from f of 2, not f of 3. So we set up our left-hand Riemann sum, 3 minus 2 times f of 2, plus 5 minus 3 times f of 3, plus 8 minus 5 times f of 5, plus 13 minus 8 f of 8. And then the values for f of 2, f of 3, f of 5, and f of 8 we grab directly from the table. So we get 1 times 1 plus 2 times 4 plus 3 times negative 2 plus 5 times 3. And when all is said and done, that is equal to 18. In part D of the question, we are given that the derivative of f at x equals 5 is 3. We are given that the second derivative of f is less than 0 for all x on the closed interval from 5 to 8. And we are asked to use the tangent line to show that f of 7 must be less than or equal to 4, and then to use the secant line between 5 and 8 to show that f of 7 is greater than or equal to 4/3. Right, kind of an interesting question here. I've seen a lot of these types of questions. This, I believe, is the first time I've ever seen these two things asked together, let alone separately. Although some of these, they show up occasionally. All right, so since f double prime is negative for all x on the interval from 5 to 8, we know that f is concave down on that interval. Well, what does that mean? If f is concave down on that interval, that means that the tangent line for any point on that interval would be above the curve, right? So if we are looking at x equals 5, and we know that this is concave down, the tangent line, specifically at x equals 5, will be entirely above the curve for every value between x, for every value of x between 5 and 8. Okay. Well, what is the equation for that tangent line? Well, we're given that f prime of 5 is equal to 3. We know that the y value at x equals 5 is negative 2. So we can write the equation of the tangent line at 5. Right? So the equation of the tangent line at x equals 5 is y plus 2 equals 3 times x minus 5. All right? So if I want to approximate f of 7 or bound f of 7, I know because f of 7 is going to be on the curve, the actual value of f of 7 has to be less than or equal to the value for f of 7 that this specific tangent line would get. Right? So if I plug in 7 for x, I'm going to get 3 times 2 minus 2 is 4. And so I can conclude that f of 7 is less than or equal to 4. Likewise, since I know f is concave down for all x between 5 and 8, we know that the secant line between 5f of 5 and 8f of 8 would have to be below the curve. So whatever the actual value of f of 7 is, it would have to be greater than or equal to the value of f of 7 that the secant line would predict. Okay, so let's find the equation for that secant line. So using the formula for slope, the equation for the secant line is 5/3. Using the point 5 comma negative 2, we know that an equation for that secant line would be y plus 2 equals 5/3 times x minus 5. All right, so if that is our secant line, plugging in 7 for x, we get 5/3 times 2 minus 2 is equal to 4/3. All right, and that must be less than or equal to the actual value of f of 7.